there is one thing you need to understand to get this problem right, and that is the modulus operation. First off, the problem statement: given an integer array nums, rotate the array to the right by k steps, where k is non-negative. So we are simply moving all of these numbers to the right by 3. And if, for example, in the case of 5, 6, and 7, they will be moved out of bounds of the end of the array. And we want them to be returned to the front of the array. And so how do we do that? Well, let me explain. Okay, here we have a big fish and we have little fishes. And here we have our array. Now, you'll recall that the indexes are 0, 1, 2, 3, 4, 5, and 6. And if we shift all of these elements by 3, that means we're going to add 3 to the index. So 0 becomes 3, and so on. 3, 4, 5, 6, 7, 8, 9, and so those are our new indexes. However, these numbers are out of bounds. Our original array only goes to index 6. So the valid indexes are 0 to 6. So for the first 4 numbers, it's no problem. However, for 7, 8, 9, they will be not stored because we don't have a place to store them. And yeah, that's not good. And so we have the modulus, or the remainder operation. And so basically how this works, if you remember, 7, you have a big fish trying to eat a little fish, like 3. So how many times does 7 go into 3? 0. So 0 times 7 is 0, and you're left with 3. So any number that is less than the number to the right of the modulus is going to result in itself. So 3 is not equal or greater than 7, so the remainder is 3, 4, 5, 6. Now, what happens when a big fish takes a bite out of an equally big fish? 0. Neither of the fish are left. You're left with that. What happens with 8? Well, if 8, if we divide 7 out of 8, 7 goes into 8 one time. 1 times 7, 7. The remainder is 1. And so you can see how 8 becomes 1. And the next time we do this, it's 2. And look at that. You have just solved rotate array, because this is the key to understanding rotate array. So all these numbers that were previously out of bounds, we have now calculated their new index dynamically. So these numbers will be moved to the beginning. They'll be moved to the beginning. Okay, so let's go back to leetcode. Here we are back in leetcode. And so this is a real solution that I made a video about. And so armed with the knowledge that we just gained, you can see that this is redundant. So this code works, of course, but k, this is 3, and the length of the array is 7, and so 3% 7 is a remainder of 3. This is redundant. You do not need this. You do not need that. That's redundant. Okay, so we make a new array that is the same length. It has all the same indexes, 0 through 6, the same as the original. And then we populate it, and we calculate the new index by shifting it by the requested number, and then doing the remainder. So the result of this, as you'll recall from the big fish, little fish, is that for the numbers that are within bounds, within 0 through 6, those numbers are all less than 7, so the remainder will be just the number. So for numbers 0 through 6, the remainder will be 0 through 6. But the minute you shift it by 3 and it becomes a 7, the remainder will be 0. The remainder of 8 will be 1. The remainder of 9 will be 2. The remainder of 10 will be 3, etc. So the new index will be changed back to the beginning, and you will have created a logical loop where it'll start over where you want it to start over. And so the new indexes will, the original numbers are going to be added to the new array in the order that was requested by shifting the elements by 3 and letting the numbers that go out of range, calculating their new index by using the length of the array and having the remainder. So these are 0, 1, and 2, so their new indexes are at the beginning of the array. And then we simply overwrite the elements of the original array. And so I think this makes sense. So this is a lot to take in. But you can see the indexes, the original indexes, 0 through 6, shift them by 3, and if you modulus them, then any number that is less than the number you're modulusing it by will simply be the number. So if 7 is the length of your array, then all of these numbers are going to be fine. The minute you get beyond the bounds of your array, modulusing it by the length of your array, logically it starts over from 0, and then 1 and 2.